Hey, everybody. Apologies for being tardy.
How's it going?
It's going good. I had something else that was running over. So today our main topic is going to be multi-cluster services. Let me just check the agenda to see if there's anything else, but I don't remember that there was. Okay, I think Jeremy, it's all you.
Awesome. Cool. Well, thanks everyone for coming. I want to talk about this multi-cluster services API. I put together a little slide deck so we can kind of track it, but this is basically all revolving around a draft KEP that I put up a PR for. That's just based on that doc that I shared a while ago, and that a bunch of people have already commented on as well. So most of that is verbatim translated, but I kind of want to touch on the key points and have a chance to discuss some of the open issues. So let me share my screen here. Paul, looks like attendee screen sharing is disabled.
I am looking into that right now. That is odd.
Well, I can start talking about it anyway, because it just starts with text. But I think so the goals that I really want to do here with the KEP are define a minimal API to support service discovery and consumption across clusters, namely consuming a service in another cluster and consuming a service deployed in multiple clusters as a single service. Then I guess when consumed from another cluster, service behavior should be consistent with current behavior. So it should
Jeremy, you should be able to share your screen now.
Oh,
sorry
awesome.
about
Okay.
that.
No worries. Hold on, just doing the system preferences dance. All right, I'll be right back.
All right.
All right, there we go. So can everyone see this?
I can see it, yeah.
Perfect. All right, so yeah, the goals here, basically we want to mimic the existing behavior as much as possible. So the target is really an experience like cluster IP, which everyone's familiar with. When consuming services across clusters, we want to create building blocks for multi-cluster tooling. And I think most importantly, we want to support multiple implementations. So non-goals, we do not want to define specific implementation details beyond general API behavior. The controller that coordinates this, there may be many different implementations. It could be decentralized with a controller running in each cluster. It could be centralized with one controller kind of acting as a hub and spoke between all your other clusters. We don't want to define that, just the API and how the service is consumed and exported. We don't want to change the behavior of single cluster services in any way. So it should be absolutely safe to enable this feature in a new cluster or in an existing cluster, and nothing will be impacted. We don't want to solve mechanics of actually orchestrating multi-cluster services. So how services are actually deployed across clusters. We just want to define the API that I guess needs to be deployed, not actually get into the mechanics of how that needs to happen. And then I'm kind of hand waving away network policy right now. That's a big topic, and I think once we have what the service looks like building blocks, then we can start talking about what multi-cluster network policy would look like. I know there's a few different takes on it right now. Cilium has one, for example, but I think that will be shaped by what we decide the service API should look like. So I've broken this up into 3 parts: making the service available, what it actually means for a service to be available to other clusters, and then how it will be consumed. And there's kind of, I'm going to give a little bit of detail on the plan to kind of refresh everyone's memory, and then talk about some of the open questions. And at any point, if there's any questions or thoughts, please chime in. So there's a lot of text here, and I'm sorry for that. So I think the biggest thing for exporting a service is to create a service export custom resource in the same namespace as the service. This is kind of the new resource that we are proposing to declare that a service should be visible beyond the cluster boundary. The presence of this object means that a service is exported based on name mapping. So you create a service export in the same name and namespace as the service you want to export, and then it's exported. Now, if we look at this, the main purpose of the service export is really conditions on the status. So being able to have the controller signal that the export has actually been recognized and that it should have had some effect. Other than that, there's not much here. There's no spec, at least not yet. There's nothing that really needs to be declared, because all we're saying is that the characteristics of the existing service should be extended across clusters. So at least in the current incarnation, there's no specific multi-cluster configuration.
Looking at that spec, it appears that it needs to have the same name as the service.
That's right. So name mapping is kind of the idea.
Is there a reason you didn't go for a selector, label selector there?
Yeah, so next slide. So alternatives. And so these are kind of open questions, and label selector is kind of the biggest one. So I want to get to that last, and then we should talk about it. But I think the questions that have come up so far, first one is there's no spec. So why don't we just use an annotation? I think the biggest reason is honestly just that service doesn't have like an extensible status. If service had conditions, there may not be a great reason not to just make this an annotation on service. The other advantage, and this is a small one, is future proofing. Like, we'll get to it later, but we haven't really discussed yet what a headless multi-cluster service could look like or something like that. So there may be some need for additional configuration, but at least as is, the only true justification for not using an annotation is that service status isn't really extensible.
Yeah, I think that I think that it's a sufficient justification that like you want to leave room for there to be a spec that like warrants this being its own distinct API that you can adopt or not on top of service, and it's not also not linked to the current implementation of service in a super strict way.
Right. Yeah, that is true, and we'll kind of talk about it at the end. But I know there's new work going on with Gateway as kind of like what the evolution of the service API could look like, and service export could still be valid in that world as well. So it may not always be tied directly to a service. So that's good.
I think it makes a ton of sense purely from the RBAC perspective. I could see a situation where an organization gives folks ownership of local services, but they don't want them actually exported for security reasons or compliance reasons.
Right. So it's really say, no, you don't have write access for service exports in this namespace. And then the other benefit of, and this is the object reference question, this came up, why not just have it point at a service explicitly? And RBAC is kind of the biggest justification there as well. This way, it's really easy to control, like, the service export will always be in the namespace in the same namespace as the service. And it's really easy to just say, like, you can export services from this namespace, but not that namespace. And
it also allows you to grant individual access to export a specific service based on the name.
Right, exactly. Whereas otherwise, we have to figure out the mapping, and then what happens, we'd have to figure out what happens if two people create exports for the same service. What does that actually look like? So this kind of simplifies things. So label selector is a good question. And I think it's definitely more flexible. Like I could create a rule that all services in this namespace are exported pretty easily, or services that yeah, with a certain label. Like there's a lot more flexibility there. The main reason for against this, and this is a discussion I'd really like to have, is it kind of complicates status reporting. Like what would it look like if one service was exported and another one wasn't? But the biggest thing is that you can actually build, like with the name map service export, you could build similar functionality pretty easily. Like you could have a controller that uses a selector to create service exports for a service when it's created. So by sticking with name mapping and not using a selector, we're not actually excluding the ability to create a selector-based implementation if you want. But it would be tooling you could build on top of the system instead of default behavior. And then you would always be guaranteed that there is a service export for every exported service that can report on basically the status of that export.
I think that's a really good point, and I think it's also worth drawing everybody's attention to the fact that this would be an alpha API, and the decisions that we make today are not ones that we have to live with forever. Right. You know, the virtue of alpha is that you can make breaking changes if you feel that it's necessary. But I also think that, like, you know, kind of skipping more complex and sophisticated selection mechanics will also allow us to focus on the details of does the concept add value, and what are the right attributes of the implementation or of the API for just a single service, without getting bogged down with details that can come later.
As a user of this, I would 100% would want to be able to do a label selector. Now that I've said that, I think your point that you can just write an operator for this, or like there's a million different ways to do it, is totally valid. I think it should just be called out that, like, again, as a user, I'm going to want to say everything that matches my app, please just export it. I don't want to go write another loop in a Helm template to go and plop all of these resources down.
Right.
And I think that I think your point is well taken. I think it is almost worth recognizing as a goal that in the current or in the regime of like name association of these resources, that we would expect and desire for people to be able to write higher level constructs. I'm sure that you could also like PR it if you wanted it to happen. And we, in a universe where like this is at a formalized API point, like I'd be very receptive to reading a proposal to add that type of behavior as a distinct object.
Right. Yeah, I like it. And maybe there's some service export policy or something that you can create that does that. Because the other thing that's come up too as an open question kind of related is, what if it's not, like, there may be implementations that are not based on labels on services. They might be based on annotations on the namespace, you know, things like that. So this way we're not really prescribing which way you want to go. There's definitely, though, consensus, I think, that some kind of higher level construct will evolve here around how you declare in advance that some set of services will be exported. But yeah, I tried to call that out in the KEP. And if it's not clear enough, please let me know that, you know, we're not saying you can't build on top of this, and, you know, we want that. Does anyone have anything else here on the export side?
Not for me. At least when it comes to like selection and naming. I would like to, do you have a slide about like what fields or what would a status of a service export look like?
I didn't really get into that right now. It's
Okay.
called out in the KEP, so we can talk about that, absolutely. I think, you know, at a basic level, my vision would be that when the controller actually recognizes the export, or adds any finalizers or whatever it needs to do. It can say initialized, or and then the status could be like it's kind of up to the controller, but the common ones I see are basically initialized, and then whether or not the export has been synced, or the exported service has been synced to other clusters, and any errors on that.
We can probably skip a deep dive on that for now, especially if you don't have a slide on it, but might be useful for us to talk about in the context of like an end-to-end example.
Yeah, absolutely. And then yes, I just figured that was a little bit bigger. I think that might be a good discussion to have on the PR or something.
Yeah.
And also it's kind of open-ended as well, because this is all talking about service export, but if you built something, or exported services in the cluster IP sense, but if you built something that used services for something else, maybe it's like load balancing across clusters, things like that. Maybe you'd have your own condition that you want to set as well. So yeah, that should be a whole other discussion. So I think the next big topic is actually, what does it mean for something to be exported? And so I'm going to use the word supercluster a lot. That's kind of what we've been kicking around, but it's definitely not the name we're actually proposing for this. But supercluster is kind of your group of clusters that are all managed together. And basically it's the group of clusters that a exported service can be consumed by. And so, there's been that proposal about namespace sameness, and it would kind of be the group of clusters that are governed by some single authority that can make decisions like this. So the concept here is the supercluster IP. And when you export a service, it would create a supercluster IP, which is just like a cluster IP, but can have backends in multiple clusters, including the consuming cluster. So just because something has been exported doesn't mean that you're not necessarily consuming it from that exporting cluster. So basically, using the supercluster IP is a declaration that you don't really care where the backends for the service actually are, and you're leaving that up to the implementation to make good decisions about. So the supercluster IP, once exported, can be accessed by any cluster in the supercluster. Again, this is where at some point we'll want to come back and talk about supercluster multi-cluster network policy, and how you could lock that down. But with this proposal, it would at least be visible to every cluster in the supercluster. We don't want to get into necessarily how this is assigned. So maybe it's supercluster wide, or maybe it's a per cluster basis. That can be an implementation decision. But within a cluster, the supercluster IP is a consistent thing, just like cluster IP today. And then it routes to some representative set of endpoints from each exporting cluster. So if I have my service in my namespace in cluster A and my service in my namespace in cluster B, a consumer in cluster C that consumes the supercluster service, my service, my namespace, gets backends from both clusters. But the term representative set was chosen specifically because an implementation may decide to do some kind of topology-based optimization or return some kind of subset. So I don't think we necessarily need to guarantee that all endpoints are synced with every cluster. That can kind of be an implementation decision. Any questions on this part?
That was actually my biggest question, was the endpoint syncing. I could see cloud bills going through the sky on that.
Exactly, yeah. So our hope is that, like, I know that there's some discussions around service topology and how that will evolve, but like we'd take advantage of service topology as described today, or an implementation could do something better if it wanted to. But yeah, we definitely don't want to make any specific statements around like all endpoints are synced for that exact reason.
The supercluster IP is actually defined on the client side for the client cluster, not the server cluster, it sounds like, as well. Or the
Yes.
You're saying the implementation can figure it out, but really the IP is defined on the source cluster, not the destination cluster.
Or yes, yeah. I've been using I've been flipping those terms, but yeah, from what you mean, the consumer cluster defines the the supercluster IP.
There we go.
Yeah.
Words are hard.
What is the source of traffic? Yeah, so it's the source of traffic. So it's, but yeah, so the consumer cluster defines the supercluster IP, but the implementation may decide that this is a shared supercluster IP that all services access, or it may scope it to the cluster. The only important thing is that it is at least scoped to the cluster. You know, we don't want to get in a world where each pod sees its own version of the supercluster IP or something like that. The DNS is obviously going to be important here, and this is probably something we're going to want to dig into a bit more. So the thinking is that we'd have a new zone, the supercluster.local zone, and otherwise it looks like cluster local. When you make a request for a service.namespace.supercluster.local, it would resolve to the supercluster IP. There would be no change whatsoever to the cluster.local zone. And so some other implementations have kind of gone a different way, but the idea here is that exporting a service should not impact existing consumers who are specifically requesting cluster.local. They should need to opt in by selecting supercluster.local instead. So this means it's easier to do gradual rollout, and you know, you don't have to worry that you're going to turn on this feature, export a service, and break a whole bunch of things that are currently deployed. Again, yeah, go ahead.
That actually raises an interesting question. Will the supercluster IP theoretically route locally as well?
Yes. Yeah, like if the local cluster exports a service and you consume it, you could just talk to backends in your local cluster, and it may be that the implementation decides if in that case you actually only get endpoints in your local cluster. You know, so yeah, that would be, but yeah, it definitely could be local. It just means that it's at the supercluster level, which also gives the service the freedom to move between clusters if needed. So I will revisit DNS a bit on the next slide because there's some open questions there. But I think the big things are exports with the same name and namespace in any cluster become a single service. Beyond that, so you know, we talked on this before, but my service, my namespace in all clusters is the same service, and those endpoints can be in multiple clusters. We've been thinking about it just disallowing external name services. I can't really wrap my head around what a supercluster external name service would be. You probably just want to create external name services in each cluster versus trying to sync something. But other than external name services, all other service types would be treated the same way. So we really just care about the cluster IP service. Endpoints are synced and there's a supercluster IP. If you were to export a load balancer or node port service at the supercluster level, it would be the same. Those would still be load balancer and node port services in their host clusters. And the node port or load balancer would just route to that local cluster, no change. I get one open question here is headless. And I didn't really call it out in the deck, but it is called out in the CAP. This doesn't really solve for stateful services yet. There's other constraints that come with exporting stateful sets. Like if I deploy a stateful set with the same name in multiple clusters, I'm going to have duplicate host names on those pods. What happens when those are actually combined behind one service? So this doesn't really solve that. And that's kind of the normal use of a headless service. However, there is a new use for headless services that comes up in this world, which is I've got a service that will only ever be exposed at the supercluster level, and I don't want to have any local cluster IP overhead. So, you know, maybe you still do want to support headless services, but your existing headless services probably won't behave the way you expect at the supercluster level today.
That actually leads into kind of another question I've got, which is somewhat DNS related. Would it be possible to opt into addressing specific clusters? So if we follow that stateless concept, if you've got a namespace there for the per cluster basis, instead of letting just the implementation handle it under the covers.
Right. So in this proposal so far, no. You know, for stateless, for example, the thinking is that which service you actually consume as a consumer is really up to the implementation and the service owner. You as a consumer are just saying, give me a service, and everybody else's job is to make it available. Obviously with stateful services we do need some kind of direct addressing. So that I would like to solve kind of in the next phase after we get some consensus on stateless, because yeah, you would need some way to address a service in a specific cluster, and maybe even a specific backend in that specific cluster.
In general, I think it's smart to start with the simplest possible set of features that could yield value, and disallow like any other type of service, right, beyond what we feel is fits that bill. It's much easier to widen the applicability of this concept in the future, or introduce parallel concepts if we need to for different types of services, than it is to like to pull back from something that we've already said X or Y thing is covered.
Completely agree. Yeah.
I think my biggest worry, concern, is having it the implementations end up having a whole bunch of spread. I'm thinking of a world where a consumer may, to your point, not actually want to necessarily address a specific cluster, but may want to, say somehow that I only want to talk to in-region things or something like that, at which point it is totally up to the implementation, but I could see that then spreading into annotations and a bunch of random implementation stuff to go and solve that specific use case.
Right.
Yeah, I think there's probably like a trade-off to be made of risk that will happen versus being able to tackle things in the simplest possible way and like have the use cases come to us. But I act that as a risk. Yeah. Totally get it.
I think your point of it being an alpha is a great one. The first implementation, like as an implementer of this spec, I would guarantee I would put annotations in to be able to do exactly that. But it's easier to design the spec once I put the annotations in as an implementer.
Right.
Oh, totally.
Right, exactly.
So much easier to extract than to plan.
Right. And then there's also the question is like, as the implementer, you may want to give that control to a consumer, but you also might want to give it to the service owner. Like the service owner really should be saying this should only be consumed local to my region. So who gets the knobs might vary, but at least with this basic spec, we can start playing around with that and see what works. So specifically on the DNS, I think a few questions that have come up is supercluster.local a standard suffix or can it be configured? There's pros and cons of both. If supercluster.local or whatever we end up going with, again, supercluster is a placeholder name, so it's a little confusing, but is there some fixed suffix that kind of becomes the normal way to access supercluster or mesh services or whatever we want to call it? Or is this something that actually needs to be configured on a per cluster basis? I'm curious what thoughts are there. The hope is that we could lean towards maybe something a little more standard. And then, if you need to configure your own DNS, you can on top of that.
I find it offensive that you can modify cluster.local, so.
That's, yeah.
+1 to that. Yeah.
Cool, so that's easy, that's good. That was kind of the answer, the feedback I was hoping for there.
It's another one of those things that's like, it's easier to like think through adding that capability later than it is to start out and say that you'll be held accountable for making sure that works from the get-go.
Right. So the KEP as written assumes that it can't be changed. So really it just comes down to the favorite naming conversation. What do we actually want to call that? But that seems less important, and like we could probably spend hours just on that as naming conversations go. And then the next question, this one's kind of more open-ended. How do we handle short name lookup? I think it's pretty clear that supercluster.local should always go supercluster, cluster.local should always go cluster local. But what happens if I've been just talking to DB, my DB or something as a service, and that goes to the local namespace service, and the search path it resolves to service.cluster.local. Should that actually resolve to supercluster.local first in this new world? Pros and cons to both. I mean, it kind of adding supercluster.local to the search path kind of does change existing services, but it also seems like it might be the intuitive behavior. So I'm really curious what people think there.
It's an awfully big foot gun.
Yeah.
It's big enough of a foot gun. I would tend to go that cluster.local stays where it is, and supercluster.local is basically requires an FQDN unless somebody changes their result. Like, maybe the best way to do this is if you go and set up a name config to change the search path to stick supercluster local, that would be how you get it, because that's an explicit opt-in through configuration.
Yep. Yeah,
Cool.
I'm
Yeah,
+1 on opt-in.
Awesome. I love it. That is the thinking that we've been having as well.
Especially considering, the probable effect on your cloud bill if you start using it without opting into it.
Right, and the implementation that you're using doesn't have region or zone preferences or anything like that. Yeah.
Or latencies, or the poor schmuck who starts putting data into the wrong DC accidentally, yep. Or like, it's a massive foot gun.
Yep. Yep. Awesome. Okay, because that's been our thinking as well. But this one, I think more than anything else has come up, and yeah, and also we also don't really know today who's using the short name, just because you can make very clear assumptions about what happens with it, and who's using it because they really don't care. I guess most people care, so that's great. And then kind of open question like we talked about, but I agree that we should leave this for after we figure out, after we get an implementation going for stateless, what does multi-cluster headless look like, or stateful services?
Do you want to actually put that as a non-goal for now and move it in later? Because that does clear up a lot of questions kind of along the way.
Yep. Yep. Okay. I will make that a non-goal. I'm quite happy with that. It sounds like that nobody really seems to have a problem with that idea for now. Cool. Awesome. So now the more fun part, how do we actually make this work? Import and connectivity. So the idea that we've had is basically we create a new CRD imported service, and there would be a CR for each unique by namespace name service that's marked for export in the supercluster. So this is basically the multi-cluster equivalent of service, just focused on that cluster IP case. It contains a union of service ports from source services. So this would be the way that we do incremental rollout. Unfortunately, service has some characteristics that don't really merge nicely, like IP family and service port. Like we would probably not be able to reconcile multiple services that use the same service port name for different ports. But otherwise, if they disagree on their export port, we could support both. If you wanted to allow a rollout of a new port, we could support that. This is one way you could discover the supercluster IP. So just listing your imported services, and it would contain all important per cluster spec, keyed by source cluster. So this way we could have, basically the goal here is that imported service would be referenced by endpoint slices, just like service is now. And the goal is that if we create a endpoint slice based on a service from an exporting cluster, we can keep the same topology keys and session affinity and whatever else associated with that endpoint slice on the imported side. So you could do gradual rollouts of topology changes, things like that. So if cluster A had topology keys zone region and cluster B had region, the imported endpoints from cluster B would be scoped to region, and the imported endpoints from cluster A would be scoped zone region. And then hopefully that would be a temporary state during a migration, but it would still allow you to do partial rollout. So what this would actually look like is an imported service resource with a spec that contains the ports, the IP family, the IP, this is the supercluster IP, and a list of cluster specs. And the cluster spec would have basically everything that is scoped to that cluster. Now, again, headless is punted, so maybe we get rid of publish not ready addresses. I don't know if that makes any sense. But yeah, so it would be keyed on cluster. And cluster is some unique to the implementation ID for that cluster. So we don't, it needs to be some kind of cluster ID. And I know there was a long time ago a proposal about a kind of uniform cluster ID, but for the sake of this implementation, it just needs to be something that the implementation can consistently use to reference that source cluster.
Yeah, I think that's a really, really important point to make, that the coordinate that you use for the cluster field of cluster spec is only required to be like mutually intelligible in the implementation that you have. It's not a coordinate in the cluster registry. It's not a cluster ID. It might be in the future, but it's not right now.
Right, right. For the purpose of this implementation, it is just some scoped, some unique identifier scoped to the multi-cluster service implementation, and that's it. And so how we use that is, well, we create one or more endpoint slice for each source cluster based on whatever scaling parameters we have on endpoint slice. So I think it's by default it's 100 endpoints per slice. Again, it contains some representative set of endpoints for its cluster, and it would reference the imported service by a new label, a new well-known label, multi-cluster Kates.io imported service name. Today we have Kates.io service name. So it looks a lot like the existing implementation, but it references imported service instead. Then we'd have this new multi-cluster Kates.io source cluster label as well. And that would be how we look up the per cluster endpoints to know how to actually apply the properties from the spec. This is the other place where that ID is used. And again, registry scoped unique identifier for a cluster, and registry isn't the right word, it's really implementation scope. So as long as the implementation can consistently use, apply this identifier, it can be whatever you want. And then the last piece here is endpoint expiry. So your implementation could potentially lose connection to any cluster, and we want to kind of normalize behavior around cleanup. So the idea would be that there's a lease created for each source cluster. Some controller periodically renews the lease in each cluster. This would be your core implementation controller, as long as the source cluster is still connected. And then there would be another controller. It might be the same controller. It might be something running local in the cluster that watches the lease and removes all associated endpoint slices with that cluster upon expiry, so that you wouldn't have a risk of a cluster becoming unreachable for a long time and having to still try its endpoints. Any questions about this general API?
The ports is the one that I've got the most questions about. It sounds like you're saying there is no normalization of ports across the clusters, and the implementation will have to figure out how to deal with that on the endpoints themselves.
Right. Well, I don't. So in an earlier draft of this, we thought about requiring that the ports just need to be normalized. But what if you wanted to roll out a new port? We need to at least support a temporary state where there's some disagreement. So the idea is we could at least try to do the right thing and take a union, as long as there's no conflicting port names. That should be okay. As long as you don't do something that seems obviously wrong, and we need to figure out the right behavior about that. But if you added a new port in one cluster, that seems acceptable.
I think that makes sense. Obviously, target ports wouldn't need to be normalized at all. You could do that
Right.
randomly. It's really the port itself. Again, as an implementation, I could see lots of issues there, like as picking endpoint slices based off of the source port and where that goes. So it might be worth at least specifying in the spec a little bit more the behavior that's expected.
Okay. Yeah, so there is actually a good section on conflict resolution. It's in the KEP. So yeah, I guess please take a look and add comments, and anything that you disagree with or needs to be clarified, please let me know. Because yeah, there's that is one part that gets messy for sure. Anything else on this section?
I mean, the potentially only other thing is I totally get where you're going with the endpoint expiry, but because there's no definition on what endpoints actually get synced, the connectivity questions there start to get big. And then it's going to be up to the implementations to try and figure out whether an endpoint is reachable or not, which is a
right.
problem.
So I guess all we've done is define it at the cluster level. So if the cluster is unreachable, because if the endpoint's gone from the source cluster, you know it's gone from all clusters. But if the source cluster is unreachable, that doesn't necessarily mean anything's wrong with the endpoints, and we don't want to get start deleting things because there's a flaky connection. So I think it would be up to the implementation to decide what this TTL is, but this would just be kind of the last resort for cleaning up endpoint slices from a cluster that was no longer reachable. Ideally, during normal operation, this is never actually used.
Right, and it feels like there's an opportunity in here somewhere for, lack of a better term, remote liveness checks of some kind, but that ends up starting to get forced down on the implementation.
Right, and yeah, and the implementation could do all kinds of clever things there about actually health checking individual endpoints. But if an endpoint actually failed a health check, you probably wouldn't rely on the TTL. You'd probably want to explicitly remove it from the set.
Totally. My question was much less around the TTL. I think that's 100% right. It was more around the general connectivity. If you go through a network split, what happens if there's connectivity down? Do you flush all the endpoints? Do you only flush some of them? Do you do a liveness check on all the endpoints from the remote cluster? Do you do it just to one? And all of the subtleties there.
Right. So yeah, that is a good question. I think maybe we should dig into that a little bit more, kind of as this progresses. I get the idea was just keep it simple to start, and we can see kind of what behaviors emerge there. Anything else here?
So is there a name association between an imported service and a service, a normal core service?
Yes. Yeah, I mean, so since the export is name mapped and the imported service is created for the export based on same name namespace, if you export a service, there will be a supercluster service, an imported service created with the same name as that service.
Can I export and import in the same cluster?
Yes. That is actually one of the main motivators for using this imported service CR instead of trying to cram this into service, so that they can coexist. You'd access the imported service via the supercluster local name, the service via cluster local, and you get a cluster IP and a supercluster IP. But you'd have two different ways of accessing it, but they would have the same name and namespace.
Gotcha. So just to make sure that I understand, the imported service is basically a parallel API that's just for exported service endpoints. Is that right?
That's right. Yeah.
And if I export in the same cluster as I import, the imported service has the endpoints that I exported from my cluster as well, right?
That's right. Exactly.
So if I just imported, I could have a distinct way to access the endpoints that were off cluster only.
If you just imported and there was no Yes. Yeah, if you just imported and there was no export, the supercluster IP would resolve to endpoints that are off cluster only.
Okay, I think that makes sense. I'm still digesting this as something that's not like a comfort zone for me personally, but like so far makes a lot of sense.
Okay, awesome. Yeah, any thoughts or feedback too as you think about this more, please. Definitely appreciate it. I think kind of going into how the things we need to do to make this work. So ideally, DNS implementations become aware of imported service so that we can actually make this standard. Kubeproxy becomes aware of imported service on our label as well. So this is something that Kubeproxy would support. So you don't have to handle routing, out of band. And the goal really is that when a controller creates these objects in a cluster, routing just works. And so that controller can be whatever you want for your implementation. It could even be manually creating, as a user to test this out, manually creating these resources. But ideally, we can get this to a point where these are recognized, well-known resources, and you can turn this feature on and just start creating these resources, and everything works. I guess there are a few other ideas that we've talked about, so I think the first one is opt-in. So this kind of assumes that an imported service is created in every cluster. This seems safe. Like automatically creating the imported service, as we've been talking about, seems safe, given that we're going with this concept of existing under some global authority who can decide to allow or disallow imports in a cluster, but basically it wouldn't be up to some cluster owner to decide whether individual imports are allowed, because a namespace should be governed by the same group across all of your clusters. Now you may have rules that prevent anything from being created in a namespace in a given cluster, but ideally you're not explicitly having to import a service. But that is something we could support, and maybe instead this looks like you create an imported service to basically grant permission to import that, and then the controller just populates the properties and endpoint slices. I guess thoughts there. That kind of came up as another approach. Personally, it's not my favorite.
So just to go back to like the support for this in Kubeproxy, do we have an option to prototype it without changing Kubeproxy?
Yeah, I think so. I don't see why we couldn't like have our own implementation that coexists. Certainly for alpha. I think there are some practical implications there, like basically IP tables is a mess, and running two different things that are controlling IP tables all the time may not be ideal. But I don't see anything wrong with that for prototyping.
Yeah, it's certainly something to think about. Like, what is the best way to approach prototyping it so that we can limit disruption to the proxy without introducing like a lot more complication in other dimensions. Your point about IP tables being a mess is well taken. Okay.
But I sorry, go ahead.
I was just going to say, as someone working on Linkerd, this is a trivial update to our discovery service, and then you just kind of get it for free without, for the prototyping side of things. I would hate to touch the IP tables rules.
So yeah. So multiple implementations could handle this in a different way. I mean, it would be, I guess, as an end goal, like by the time this was taken out of beta, at least, or hopefully taken out of alpha, but definitely by the time it was taken out of beta, ideally it would be a first-class citizen. If it was a flag, it could definitely be a flag, so not enabled by default. But it would be great if you didn't have to run some competing kubeproxy implementation to make this work.
Yeah.
Something
to think about in the next couple beats, I think.
Yeah, I think, but I definitely think, you know, we can start prototyping without this, as long as we're just thinking about how this would work eventually. I wouldn't want to get in a world where we have to have the you know, competing IP tables programmers.
Totally agree. And I also don't think that we should block, you know, implementation work on finding the just right way to do it, because there are likely to be so many different implementations, right?
Absolutely, absolutely. Cool. And so I guess the last thing I wanted to mention, I don't think this needs a huge amount of discussion yet, but we have been thinking about the, you know, gateway API and how that evolves and how this would work. So maybe there's a future where imported service is actually replaced with a gateway and a multi-cluster route. You know, I guess it depends if that becomes the new standard way to do non-traditional services. We'd probably want this to evolve the same, but it seems like this this general approach fits. So I don't think, you know, the details of that are important yet.
I'm pretty ignorant about the timeline associated with Gateway. Like, does anybody have a good read on that?
Yeah, I'm not completely sure. I know there's been a bunch of progress. There's I was at a good meetup at KubeCon in San Diego, but I'm not exactly sure. You know, I think it's steady but careful evolution there. So I don't know exactly what the timeline is, which is kind of why this is starting with imported service. If Gateway was going to be out tomorrow, I think there'd be no question this would be trying to figure out how to design with Gateway in mind, but I think it just makes sense to start with a new CRD.
Well, either way you slice it, probably a lot more people are using service than maybe using Gateway.
Right, exactly. So cool. So we're almost out of time, I guess. What are next steps, and I guess what would be needed to, you know, get this proposal accepted as something that you know, we can work towards making it implementable?
That is a very good question. It has been quite some time since I personally worked on something that had a chance of affecting the core API. And I must be open about the fact that I'm unsure of what the right point is to be at before you merge the initial KEP. So that's something that I need to do a little bit of research on. Okay. I think you should keep going, Jeremy, and we should think about like what's the best, most widely applicable way to prototype this. And I'll do my due diligence on like what are the current norms around merging KEPs initially.
Okay, cool.
I think maybe actually we've skipped over something important though. I think that what your intention would be is to have this be part of the main Kubernetes API. Not in the core group, but in like Kubernetes API.
Or something maybe to start. But yeah, eventually, ideally, this would be part of the main Kubernetes API.
Okay. Yeah. I think maybe then next steps are us to figure out like, are we trying to do something that will wind up in Kubernetes API repo? Are we thinking that the API would live in maybe Kubernetes SIGs? What are the coordinates that we're expecting to write to for the API? Or write the API into, if that makes sense.
Right. Okay, yeah, that does make sense. Yeah, and I think that's kind of, I think we probably need other SIGs to weigh in on that as well. Like, is this something that could be comfortably incorporated into core Kubernetes API, or does this stay just as a, you know, a SIG extension?
Mm-hmm. Okay, well, thanks a lot for the very detailed presentation today. Really appreciate it. Thank you.
Yeah, thank you. Thanks everyone for weighing in. Please check out, it's linked in the meeting notes for today, but please check out the PR for the CAP and add a ton of comments and, you know, pick it apart. That would be awesome.
All right. So next week's meeting will be on workload API as the main topic. Thanks again, Jeremy. See everybody. Have a great day.
Thank you all.
All right. Take care.
See you next
Bye.
week.
Bye.